Okay, great. Let's get started. Hello and welcome. Thank you all for joining me today. My name is Matthew McRae and I'm the Biotechnology Sales Product Line Manager for Nova Biomedical. I'll be taking you through today's webinar titled Osmotic Shock and Cell Count Accuracy, Ensuring Accurate Cell Density and Cell Viability Measurements. Just a few things I'd like to cover before we get into the details of the webinar. First, this webinar will be recorded. It will be available on our website. So if you would like to review the webinar in the future, or if you have some colleagues who are unable to attend today's webinar, you can go to our website at www.novabio.com, navigate to the webinar section, and from there you can access the recorded content of this webinar. Also, I've left about 15 minutes at the end of this webinar to answer any questions that anyone would have, but please post those questions in the chat section, and I will do my best to get through those questions at the end. The agenda for today is as follows. First, we will discuss the evolution of Nova's bioprofile products as it pertains to cell counting technologies. Then we will discuss how we uncovered the issue that we're going to outline today, which is specifically the effects of osmotic shock due to manual sample pre-dilutions and the impact that that procedure has on cell count accuracy. I'll summarize the year of extensive investigation and the steps we took to test and confirm our theories. Finally, I'll summarize the critical design elements that you should consider when selecting automated cell counters for your laboratory to ensure accurate and reproducible cell counts. Finally, I will answer as many questions as I can in the remaining time. Nova Biomedical introduced its first bioprofile analyzer back in 1998. That instrument was a relatively simple instrument providing measurements for pH gases and basic chemistries. Due to market demands, Nova designed our first automated cell counter as part of the Bioprofile Flex 1 in 2008 with the goal of providing one instrument capable of analyzing all critical cell culture tests with one sample, eliminating the need for multiple instruments. A few years later in 2016, we released the Bioprofile Flex 2 analyzer, and most recently in 2022, the Bioprofile Fast CDV analyzer. All three of these technologies utilize image-based analysis for cell density, while incorporating trypan blue dye exclusion for quantification of viability. All three of these technologies are quite unique in the marketplace, providing one key design element that no other technology has, which is onboard and automated dilutions. Cell culture samples can be analyzed without external dilution up to a concentration of 160 million cells per mil, which addresses the needs of almost all cell culture applications, including high-density perfusion cultures. It is this unique feature that has set us apart from other technologies available on the market, and as you will see, led us to identify a critical flaw in other technologies as well as in most laboratory workflows. So I assume most of you are here to learn about our discovery of osmotic shock and how it can drastically impact your cell count accuracy. So let's discuss how we first identified this issue. And before we do, I need to detail the implementation process of our bioprofile devices. When a customer purchases an analyzer and the installation is complete by our field service engineers, our applications team will coordinate with the customer to execute a comparability study. The goal is to optimize the algorithms on the bioprofile analyzer to provide comparable results to the reference analyzer. It's as simple as that. We can do this for all parameters we measure, including pH, gases, chemistries, but the most common parameter requiring alignment is cell density and viability. Nova was not the first to market with an automated cell counter, so over the last 16 years that we've been selling automated cell counters with our Flex 1, Flex 2, and Fast CDV, alignment is almost always requested by the customer. So we have over a decade of experience in aligning our technology to almost any reference method being used. Okay, so how is it performed? Pretty simple. A member of our global applications team schedules a visit with the customer, which is free of charge, I'd like to emphasize. Prior to going on site, the application scientist coordinates with the end users to ensure they have access to cultures that can be sampled from that represent all cell lines as well as all cell densities and viabilities. The protocol consists of measuring 7 to 10 replicates of samples at low cell density, moderate cell density, and high cell density, as well as high viability early stage cultures and low viability late stage cultures. The goal is to adjust the algorithms on the analyzer and create one cell inspection type that can be used for all process stages, including scale-up and production, low density through high density, and high viability through low viability, while providing results within 10% of the reference analyzer. The phenomenon that I'm going to discuss today manifested itself several years ago when our applications team was performing one of these comparability studies with one of our customers. Our applications team obtained a CHO cell culture from a range of early stage and late stage production cultures and analyzed 10 replicates of each of those samples on both the bioprofile Flex 2 module and the reference analyzer. I'm not going to name the analyzer, but the customer's reference analyzer was a very common trypan blue dye automated cell counter. Also, to protect the customer, the data shown here was obtained by one of our local university partners using a non-transfected CHO parent, but the data is very comparable to the data that began this investigation. The data looked very promising with low cell density, but as you can see, the results began to deviate at cell density concentrations above 10 million cells per mil. Results that were within 10% at densities below 10 million cells per mil now were becoming increasingly different at higher cell densities, and a very noticeable break in the data at 10 million cells per mil. It may not be that apparent in the slide, but let's focus on just the sample replicates from the high cell density cultures, which were at approximately 19 million cells per mil. Here you can see a significant trend downward for the samples analyzed on the reference analyzer, which is shown in red, with very good reproducibility on the bioprofile Flex 2 with no significant drop in viable cell density over the 10 replicates. That's shown in the blue line. This just didn't make sense to us. We began a very extensive investigation that would take us almost a year to identify the root cause of the problem. Should be pointed out that how we processed these samples, we prepared 10 samples for the Flex 2, 10 samples for the reference analyzer, and because those samples were above 10 million cells per mil, we had to pre-dilute those samples at a 1:4 dilution to ensure that those samples were within the upper range of the reference analyzer, which at the time was 10 million cells per mil. So a 1:4 dilution with PBS was performed prior to loading those cups on the tray. So as a reminder, all 10 of those replicate samples were all prepped at the same time, all diluted at the same time. So the difference between the first sample and the last sample was approximately 30 minutes. I should also point out from this slide that the Flex 2 data was very acceptable for the customer. The issue that we found moving forward was that it really seemed to depend on the amount of time that the sample sat after dilution. Sometimes we would see very good results, sometimes we would see very different results, and that posed a significant challenge to us because sometimes our results seemed to be 10 to 20% higher. We would run the same sample processed in a shorter time from the time it was sampled and diluted, and we would see very comparable results. So this was just very mind-boggling to us. We couldn't really optimize the algorithms because we just were not seeing consistent results between the Flex 2 analyzer and the reference analyzer. The first thing we did was just list all of the possible inputs that could create this deviation. Things like pipetting or pipetting error, inadequate vortexing or mixing prior to performing any manual pre-analysis dilutions. And as a reminder, this is only necessary on non-Nova cell counters. As I mentioned before, the Nova cell counters perform all of the dilutions for you. No need for external manual dilutions. We also looked at sample cup material, the Flex 2 CDV versus our reference method that we were using. They do use different cups. Could one cup be causing more cell adhesion to the walls of the cup, thus resulting in lower cell densities? Because the trend was down, we assumed that this was probably one of the likely scenarios. The more time the sample sits in the cup, the more adhesion you have with the cells to the walls of the cup. Instrument mixing routines. Obviously, different instruments have different mixing routines, meaning inadequate pellet resuspension by one instrument leading to lower reported cell densities. This was what we believed was the most likely culprit of this phenomenon, but turned out not to be the root cause. After many months of testing, we observed this phenomenon only with samples that were manually diluted. We began manually diluting samples lower than 10 million cells per mil, and the same trends were observed in about half of the culture samples we tested. What was different about these two samples other than the cell density? We needed to investigate what could be going on at a cellular level that could lead to these results. The most obvious difference between these cultures was the osmolality. Higher cell density cultures typically have higher osmolality due to feeds, as well as pH-controlled solution additions like sodium carbonate or sodium bicarbonate. Most of the lab scientists we have worked with use PBS to dilute their samples. PBS has an osmolality of about 300 milliosmol per kilogram. Could this rapid change in environment, specifically osmolality, be causing this issue? This made us hypothesize that this immediate change in osmolality and basic physiology of passive water transport across the cell membrane could cause the cells to take up significant water to equilibrate the extracellular osmolality with intracellular osmolality. The first question we needed to ask was, can we observe the change in cell diameter as a function of the difference between the diluent osmolality and the culture osmolality? If we could observe a change in cell diameter, then we could move toward the hypothesis that the rapid increase in cell size could lead to cell lysis and loss of viable cells in the sample. To test this, we performed the following experiment. First, we obtained a cell culture sample at approximately 300 milliosmol per kilogram. Next, we created 5 separate diluents using trypan blue and a stock sodium chloride solution to achieve 5 different diluent concentrations ranging from 250 milliosmol per kilogram to 450 milliosmol per kilogram. We used those diluent samples to create 5 unique samples diluted 1 to 2, which resulted in final osmolality between approximately 280 and 300 milliosmol per kilogram. We then analyzed these samples on our bioprofile Flex 2 and reported cell diameters are shown in the graph here. As you can see, the diameters change quite drastically with changes in osmolality. While this is opposite to what would happen during normal sampling, the experiment was executed in this way to eliminate any variables associated with taking samples from different bioreactors with different osmolalities. Nonetheless, it can be said with certainty that a rapid change in osmolality certainly leads to almost immediate change in cell size. Okay, so let's go back to the original graph where I showed the replicate results from the Flex 2 compared to the reference analyzer. So the question is, why did we not observe the trend downward in viable cell density with Flex 2? The answer is simple. Even though the Flex 2 does dilute with trypan blue and an onboard diluent, if necessary with higher cell densities, the amount of time the sample incubates in that diluent is very short. This phenomenon is consistent with all of our cell density modules and analyzers. The dilution occurs immediately prior to analysis, and thus the analysis is complete before the cells have completely adjusted to the osmolality and ultimately begin to burst. This is what makes our technology so unique in the marketplace. I would like to highlight a few key features of our newest technology, the bioprofile FastCDV, and how it eliminates inaccurate cell density measurements as a function of osmotic shock, but also eliminates many other errors that can be introduced into the sampling process, such as pipetting and dilution errors, inadequate mixing, as well as incorrect dilution selection. To date, no other technology incorporates an onboard automated dilutions. Even newer technologies brought to market just a few years ago have upper analytical range restrictions as low as 15 million cells per mil. We know with advances in cell line and media development, almost all cell culture processes exceed 15 million cells per mil in just the first few days of the production process and can achieve cell densities more than 100 million cells per mil, requiring manual external dilutions for the majority of sampling days. So as I mentioned in one of my first slides, we just recently launched the bioprofile FastCDV back in 2022. This is a standalone cell counter designed for rapid, accurate cell density and cell viability results for all cell culture laboratories. As with our other automated cell counting technologies, the FastCDV requires no sample pre-dilution, thus eliminating any osmotic shock, really regardless of the cell density or the culture osmolality at the time of analysis. Bioprofile FastCDV has a throughput of 45 samples per hour and an analysis time of just 82 seconds. But more importantly, the time between the dilution step that the instrument performs and the analysis begins of the processing of the images is less than 15 seconds. So again, completely eliminating any osmotic shock that you would observe if you had to pre-dilute your sample, and the amount of time that that sample sits in that diluent can drastically impact the accuracy of your results. As the name implies, FastCDV is fast, with the ability to analyze over 45 samples per hour from both load-and-go carousel tray, which is a 32-position tray, as well as 96-well plates. Nova has developed our own 96-well plates with internal geometry identical to our carousel cups to ensure optimum mixing and comparable results between carousel and 96-well plates. FastCDV incorporates onboard and fully automated dilutions, eliminating all external dilutions for samples ranging from 50,000 all the way to 140 million cells per milliliter. Nova's development team worked extensively with our development partners to ensure accurate cell counts for the most common and a lot of the uncommon industrial cell lines, including CHO, NS0, Hybridoma, SF9, Vero, HEK, and many others, including alternative foods, beef, pork, chicken, egg, fish, and shellfish. Fast CDV's high-capacity plug-and-play reagents reduce maintenance and can be installed in just seconds. Reagent packs have a use life of 500 samples, which is the industry leader in this market, and a use life of 90 days once installed. Packs also have a shelf life of 18 months, making ordering and inventory much more manageable. Fast CDV incorporates 2 sampling options, which means it is highly adaptable. It provides the best workflow for all cell culture applications, from cell line development through commercial manufacturing. An external 32-position load-and-go tray allows continuous addition of samples, even while the analyzer is running, which is a common workflow for bench-scale cultures, as well as batch processing of small batches of 30 samples or less. For large batches of samples of more than 30, the 96-well plate capabilities of the Fast CDV provide analysis of a full plate in just over 2 hours. Nova's novel proprietary 96-well plates were designed to complement our load-and-go cups to ensure comparable results between sampling modes. So what can we conclude from this? If you absolutely must use one of the automated cell counters that requires external manual sample pre-dilution prior to analysis, it is imperative that you present the diluted sample to the analyzer within seconds of performing the manual dilution. Using these technologies eliminates the option of batch diluting multiple samples because the resulting incubation period could have tremendous negative impacts on your cell count accuracy. So of course, we suggest using one of Nova's automated instruments, such as the BioProfile Flex 2 or the new BioProfile Fast CDV, which eliminate manual dilutions and ensures accurate results across all cell densities and all culture conditions. I would also like to provide more details on what our applications team can provide as far as support. We have a very comprehensive laboratory evaluation protocol, which we can provide to you for your review, and this basically is what our applications team will use as a protocol to come on site either during a sales evaluation process. So if you are interested in evaluating one of our technologies, whether that's the Flex 2 with CDV or the Fast CDV, we can provide you this protocol. This is just gives you an idea of what we can evaluate and test and provide comparability data to support your adoption of the technology in your laboratory. Again, we have experience with many different cell lines, experience with many different reference analyzers, including Vicell XR, Vicell Blue, Chemometec, the Nucleo Counter, the Countess, many different technologies. And our applications team, as I mentioned, it's a free of charge service. We provide that support pre-sale and post-sale, and that service is available to you for the life of the device. So if you have additional cell lines, additional phenotypes in your labs moving forward after the instrument is installed, our applications team will come out globally at any time and perform additional studies to either optimize existing cell inspection settings or create new cell inspection settings for new cell lines. And again, our applications team is very experienced. We have decades of experience in doing this, and it's something that we offer for all of our instruments. We also have a very extensive comparability report where we compare the results of the BioProfile Flex 2 CDV module and the BioProfile Fast CDV results to the Beckman-Coulter Vicell XR, as well as the new Vicell Blue. And that comparability report is available free of charge. We can send that to you if you reach out to us via the web, via phone, or just contact your local sales rep. We'd be happy to share that comparability report with you. On behalf of Nova Biomedical, I'd like to thank you for taking the time to hear our presentation today. For more information on the products that we spoke about today, or any of our products, please visit our website at www.novabio.com. And with that, I'd like to open it up to some questions.
My apologies for the slight delay. We do have a few questions, but please continue to type those into the chat box. if you have any, as I'm going through the questions that we already have. So the first question is, where do you have fast CDV instruments installed? That's a great question. The product is 2 years old at this point. We've been very successful in implementation for the fast CDVs. We have units installed across the United States. We have units installed in the Asia-Pacific region, in Japan, China, Korea, Singapore. We have also units in Ireland, the UK, Germany, Benelux, and some other European countries as well, which I can't remember off the top of my head. But we do have instruments installed throughout the world, all the way from cell line development through commercial manufacturing. About 30% of our instruments, including both fast CDV and BioProfile Flex 2 and some of our other technologies, we have about 30% of our instruments installed in commercial manufacturing suites. Second question is, can you explain more about the cell size change with osmolality? Yes, I think I understand the question. I'll try to answer it as best I can. So the cell size change that we observed about a 1 micron change in cell size for every 25 milliosmo per kilogram change in osmolality between the diluent and the sample. So as an example, if you had a sample from a bioreactor that was 350 milliosmo per kilogram and you diluted that 1 to 2 with PBS at 300 milliosmo per kilogram, obviously with that 1 to 2 dilution, you would end up with an osmolality of 325, which was 25 milliosmo difference, lower than what you would have in the bioreactor, and the resulting change in diameter was a 1 micron change in diameter higher. So that is pretty significant. This webinar is focused specifically on the accuracy of your viable cell density, but if cell diameter is important to you as well, please know that when you're doing external dilutions and your osmolality is significantly different than your diluent osmolality, your reported cell diameter is going to be relatively inaccurate compared to what the diameter of those cells are in the environment that they were just taken from. Obviously, the dilution ratio that you must perform has a tremendous impact on that. As an example, if you have very high cell density at 100 million cells per mil, and you have to do a 1 to 10 or an even 1 to 20 dilution externally on some other reference methods, you could be impacting that osmolality even more, because the ratio of the diluent to the sample is obviously even higher. So you could be impacting not only your viable cell density, but your cell diameter quite significantly. Okay. So those are the two questions I have. Does anyone else have any additional questions that they'd like to put in the chat box? We have some extra time here that I'd be happy to take any questions that you have. There's a question regarding the cost of the fast CDV reagents. The cost really depends on the region, and we do have some discount pricing depending on the market and depending on the customer. I would just ask that you reach out to your local salesperson. You can contact us through our website as well, and we can provide the most accurate cost of reagents depending on where you are in the world. So there doesn't seem to be any additional questions. So with that, I will end the webinar. I want to thank everyone for joining today. I know it's early in the morning or late in the day, depending on where you are in the world. I'd just like to thank everyone for attending. As I said in the beginning of this webinar is recorded or has been recorded and will be posted on our website. You can go and get a download of that webinar at www.novabio.com. And from there, you can just click on the Events tab on the website, and under that, you would see the webinars. We have a number of webinars that we've posted over the past few years as well. So not only will this webinar be on the website, but we do have many other webinars talking about Flex 2, Amber integration, automation, a lot of different aspects of what we provide for analytical solutions for customers. So please visit our website. If you have any questions as well, you can also go to the website. There's a link there that you can contact us, ask us any questions that you have, and please visit our website. So with that, thank you. Everyone have a great day, and we'll talk to you soon. Thanks. Bye-bye.